Good morning, guys. 10 a.m. Let's start our class. Today we will practice compound interest questions. So I'm going to start with formulas. Formulas. Okay, so future value, also known as a term deposit formula. Why term deposit? Because you put money and you wait for the agreed term. That's it. So present value. Okay, what here I is J over M, N is Tm. Okay, and we know that here we move money together with time, here we move money opposite to time. Then we know how to find N. Okay, and this formula pairs with this formula. Then we know how to calculate I, and pair to this formula is J is I times M. What else? Finally, we know how to calculate effective rate of interest. That's it. Any questions? Okay, let me know when you're done writing the formulas. Okay, good. So let's do it. Western Savings offer 3-year term deposit at 225 compounded annually, while your credit union offers such deposit at 2% compounded quarterly. If you have 5 grand to invest, what is the maturity value of your deposits? Okay, guys, what 2 minutes? Find answers for A and B. Go ahead. Okay, people. So basically, let's start with A. We have 225 compounded annually. So future value 5,000, 1.0225. And now such deposits, 3-year term. So 3. Do you have the same equation? Guys, 5, 3, good. Or 5, 15. That's the answer. Okay, for B, future value is 5,000. Now quarterly, what do I have? 0.005, and then 3 years times 4 is 12. So let's see. 5308, 39. So which one is better? People, what is better? First one, yeah, very good. Any questions? Okay, let's continue. If 6,000 is invested for 6 years and 7 months at 6% compounded semi-annually, what is the interest that the investment earns? Okay, guys, take a minute, do it. Okay, so many people have, actually many people did do mistake here, and I explain what mistake in a moment. Okay, so for how, for 6 years, so 12. They find just the future value, and that's about it. 8554, 57. Do you have the same answer for future value, guys? Okay, very good. But question says, what is the interest? Right, so that's the answer. And interest is a difference between money at the end of the game and money at the beginning of the game. Of course, if we invest money, we have term deposit. So $2,554.50. That is the answer. Any questions? I hope, guys, that you actually solving those questions on your own, not waiting for me. So determine the present value and compound discount. What, 2 minutes? Go ahead. Okay. So A, present value 3600, 1.04 minus 18. Right? 9 years, so 104 exponent 18 negative times 3600. Oh, interesting. Okay, that's 1777706. Do you have the same answer for present value, guys? Okay. So now compound discount, it's the same interest. Okay, so 3600 minus, so 18 to 294. So same thing we do for B. So 9,000 due in 5 years, so it is a future value. And 6.8% quarterly gives me 0.17. Now 5 years quarterly, it's 20. Okay, let's see. 6,424.27, and interest is 9,000 minus 6,424.27. Okay, what I have 2,575.73. Okay, any questions, people? So far so good. Next one. Ted deposited 1715 RRSP on March 1, 2018 at 3% compounded quarterly. Subsequently, the interest rate was changed to 4% monthly on September 1 and 4.5 compounded semi-annually on June 1. What was the value of the RRSP deposit on December 1, 2024, if no future changes in interest were made? So how long would you like for that question, guys? 3 minutes is fine. Okay, take 3 minutes. Do it. Okay, guys, so what we have here, we have multiple transactions, right, in form of interest rate change. I recommend to create a timeline. So March 1, 2018, then next stop is September 1, 2020. Okay, finally, not finally, next stop June 1, 2022, and final stop is on December 1, 2024. Okay, so what we had 1750 here and no additional deposits, right? So the game was about interest rate change. So here J4 we have 3%. Okay, then here I had J12 4%. Okay, and J2 4.5%. So did you have the same picture, people, if you had any picture? So who had the picture in the first place? Say I. Okay, good. So second step is, it's very good that you did the picture. Second step is to have correct picture. So let's see, let's work with time now. Since we have quarterly here, right? Basically, I need to know how many quarters in that time interval. So from March to March, I have what? 19, 20, 2 years, and then April, May, June, July, August, September, 6 months. So 2 years, 2.5 years. Okay, so this one is done. Now, next interval is about what? September to June. So we can overshoot the count. We set 2 years, and then from June to September, July, August, September, 3 months. So take away 3 months from 2 years, I have 1 year, 9 months, right? So 175 years. Yes, guys. You have the same time interval. Now from June to December, we have 2 years, and then July, August, September, October, November, December, 2.5. Okay, now tell me, do you have the same time intervals for all three? Guys, okay, very good. Very good. So let's do the first interval. First interval, what is it? Future value. It is 1750. And here I have, where's my calculator? When are we gonna have spring, guys? It was snowing this morning. Come on. So that's the interest rate, and then 2.5 years times 4, I have 10. So 1,075 exponent 10 times 1750. So $1,885.77. So this amount is right there. So any questions regarding that time interval calculations, people? So second, future value. Now 1885.77 turns to present value. Now 4% compounded monthly gives me 1.003 in period, right? So, and then 175 times 12 is 21. So I call 0 exponent 21 times 1885.77. So $2,022.27. So this amount, it's right there. Okay, guys, why so quiet? Are you following me? Okay, do you have the same numbers? Okay, very good. So step 3, I think I can fit it here. Again, future value. So 20, 22, 27. Interest rate 4.5. Compounded semi-annual. It gives me 0.225. Now semi-annually it's 5. I have 2,260.25. Okay, and that is actually the final answer. What was the value of the RSP? So we just found it. Any questions, guys? So here to remember, at the point of transaction, we stop, recalculate all the values, all the balances, right? And we'll start a new process with new values. That's it. So can we continue? Okay. A demand loan of 8,000 is repaid by payments of 3K after 15, 4K after 30, final payment after 4 years. If interest was 8% for the first 2 years and 9% for remaining time, and compounding is quarterly, what is the size of the final payment? Okay, guys, what the 1, 2, 3, let's take 3 minutes. Do it. Okay, guys. So demand loan, what we have to remember here that we do not need a focal date, right? So we just do we use declining balance method and basically moving step by step from transaction to transaction. So I have now, I have 8,000 to start with, 15 months, 3,000, 30 months, 4,000, 4 years, I put 48 months, right? So to make consistent with the timeline. So interest. So what it says, first 2 years, and 2 years, it is what, 24 months, right? It is 24 months, and we had J4, 8%. So then after that, we had for the remaining J4 9%. So that's what situation what we have. Any questions so far, guys? Did you have same picture? Okay, very good. So how many transactions we have? We have deposit, we have interest rate change, that's 2. We have deposit is 3, and finally we have final payment. So 1, 2, 3, 4 stops. 4 stops. So let's do it. 15 months. Okay, so 8,000. 8%, 1.02, 15 months, what is it, 5, right? 15 divided by 3 is 5, right? Okay, so let me calculate. My God, it's 10:30 and so dark outside. Let me put on the light. I don't see anything. Okay, so 1.02 exponent 5 times 8,000. So 8, 8, 3, 2, 65, right? And I had a deposit. So let me just do this, minus 3,000, right? So what is it? $5,832.65. Okay, so step 2. Step 2, I have same 8% for next 9 months. So 5,832.65, 8%. 9 months is what? Quarterly is 3, right? Times, that is 6,189.65. So far, guys, any questions? People. So this amount is here. This amount is here. So at the point of 24 months, we didn't have any because you paid $3,000. You're paying back loan, Sawa. Okay, very good. So question 3, I mean step 3. We did at the point, we are now at the point of 24 months. and no deposits, nothing. So interest rate change only for the next 6 months, right? So 1 point, what is it? 0.225. 6 months is 2. So let's see. So I have 6,471.32, and I have 4,000 deposit. So minus 4,000, that's 2,471.32. So this amount is right there. Okay. Let me know when I can flip a page to continue. Okay, so next, what, 18 months, right? Next 18 months. So 2,471.32. Interest is 9%, right? Quarterly. 18 months, what is it? 6, right? Two eight, 2,429. That is actually the answer. Let me know when you're done. I have one more question for you. Guys, how's it going? Are you ready? Okay, now question, and one more question. What was the cost of that loan? If you know the answer, say I. If you know how to find the answer. What is the cost of that loan? People who knows the answer, say I. Well, silence, right? So remember till the end of your line. Life. Till the end of your life. Remember this. Cost of the loan, it is interest you pay. How to calculate interest on the loan? Interest on the loan equals amount that you paid. What did you pay? 4,000, and this amount what we calculated. 3 plus 4 plus 2,824.29. minus amount you borrowed. You borrowed $8,000. So that is cost of the loan, or what is it? $1,824.29. Is it? Yeah, it is. Any questions regarding that moment? Okay, next. An obligation of 10,000 is due 1 year from now with interest at 10% compounded semi-annually. The obligation is to be settled by a payment of 6K 6 months and final payment in 15 months. What is the size of the second payment if interest is now 9% compounded monthly? Uh, Guys, you want to do it? That's okay. Let's skip it. Let's skip it. Debt payment, let me see again. Obligation, 1 year with interest. Okay, let's do it. 2 minutes. Go ahead. Okay, guys, let's see what we have. We have now 1 year. That's 10,000. 10% compounded semi-annually, right? So 1.05 exponent 2 times. That's actually mine, right? Okay, so instead of that, we have 6 months, $6,000, and 15 months final payment. So final payment, it is focal date. All right. So let's find. Yeah. First of all, before I continue, did you have same idea, same picture, guys? People. So 10,000. 1.05 squared. Let's calculate what is that. Times 10,000. 11. Oops, 11. Oh, God. I love that. 11,025. Now we need to bring it to the focal date, right? And that would be 1.0075. That's 9% monthly. And focal date is what, 3 months? So it is 3. So 1.0075 exponent 3 times 11,025. 493. So that's agreement 1, right? Agreement 2, it is 6,000. What we have 9 months, right? Plus X. So let's calculate. 641737 plus X. So far, guys, any questions? Okay, so now we make those guys equal. And from here, X is what? 7493 minus 641737 485756. That is the final answer. Do you have the same number, people? Okay. So, guys, is everyone ready to continue? Guys, can we continue? Say something. I know Ariel has. Okay, good. Here, let's do this one and have a break. That payment of 4,400 due today, 500 due in 18 months, 900 due in 3 years, are to be combined into a single payment due 2 years from now. What is the size of the single payment if interest 8% compounded quarterly? Oh, well, let's take 3 minutes and do it. Go ahead. Okay. Okay, let's see. Let's see. Timeline. So now 400. Sorry. 18 months. 500. 3 years. What is it? 900. And 2 years. I have that single payment, right? So focal date is here. Let's do it. So since I have already one payment, focal date, and it's a known payment I'm looking for, so I don't see any benefits from calculating agreements separately. I just can create equations just like that. So 400 has to be moved to the future. That's quarterly 8%. And I have 2 years quarterly, it's 8, right? Plus 500, 02, so 24 months minus 18 months is 6, it's 2 quarters, right? Plus 900, so 3 years, 36, actually 3 years minus 2 is 1 year, so minus 1. That's the equation. Do you have the same one, people? Okay, very good. So let's quickly calculate. Oh, yes. Gremlins on regular basis arrive to my calculator. So I have to watch, same as you. Plus 1.02 squared times 500. You guys watch my numbers, compare them. So we are okay. Times 900. So I have 831, 46. So now add them up. 46866 plus 520.2 plus 831.46, and I have $1,820.32. Yes or no? Guys, do you have the same answer? Okay, very good. So let's have a break. Here's the question, and we do it right away after break. So if you have desire, you can do it. But if not, we do it together. So at 11:03. So break. Okay, people, break is over. So let's do this question. So we have a low. 2 years ago, it was $7,000. Okay, that's now. And we have payments, 2 years and 3 years. Okay, 12 monthly. Again, focal date in this case will be now, right? So because I have only one payment in agreement one, which is loan, I don't see any benefits to writing calculating agreements separately. So all I have to do, I have to bring 7,000 to focal date, right? So that actually agreement one, and that is agreement two. So that's our equation. Let me know if you have any questions. Okay, let me calculate. So 8888 equals x plus 0. Do I have next page? Just to make sure. Yes, I do. So 7875666127 x plus. And again, I memorized that to my calculator's memory. 69892495x. So let me know when you're ready for me to flip a page. Guys, are you ready? Okay. So now I add these coefficients together. So what I have 8, 8, 8, 8. What was it? 14 equals to 2.48649107 times x. So x from here. Wow, some funny number. So one more time. $3,574.57. So please confirm my value. So people, how it's going? Did you find the same number? Okay, any questions here? Okay, no questions. Okay, oops. At what nominal rate of interest compounded quarterly will $380 interest in 6 years? Okay, take 1 minute, do it. Okay, so what do we have? We have present value 300, future value we have $380, right? M is 4, and here is future value, just sake of I. So future value 380 over 300, 6 years. So what do we have? Quarterly, so that's 24, right? Minus 1. So I is, let me calculate, 380 over 300, exponent 0.009898 and here I remember to finish with times 4, 0.039592795. So J4 approximately 3. Let's put 9593%. Any questions, people? Okay, next. Determine the equated day at which two payments of 600 due 4 months ago and 400 due today could be settled by a payment of 1100 if interest is 725 compounded semi-annual. Okay, take 2 minutes and do it. Okay, guys, let's see. Two payments 4 months ago, 600. That's now 400. And we need to find date when we can pay 1100. So focal date is today. It's always today in questions like that, right? Let's create equation right away. So let me see semi-annual, right? So, okay, 600, oops, row 2, 600, 1.03625. Now, semi-annually, 4 months, let's find it, 4 over 12 times 2. That's 0.6 in period. That is n plus 400 equals 2, 1.03625 minus n. So that is equation. Any questions? Does everyone understand that exponent here, 0.6 in period? Okay, silence. It means, oops, that you do understand or don't understand. Okay. Now what I have, 1000, 1441 equals 2. 1100, 1.03625. So guys, till this moment, any questions? Because I'm gonna flip the page. So what is this? This is present value, right? This is future value. And I have, so n is logarithm 1100 over 101,441 logarithm 1 point, what was it, 0.3625. Oops. 0.3625. Let's calculate that. 2.274827137. And now T is n over m, right? I have semi-annual, so I divide by 2 for each 27137 over 2. So T is 1.137413568. Now I might want to have answer in months. So that's years times 12. Approximately 13.65 months. Well, it depends what they want, years, months. Or they want, let's say it would be 1 year and what? And 2 months approximately. 2 months. Okay. 1 year, 2. Any questions, people? Okay, let me know when you're ready to continue. Okay. In how many months will money double at 8% compounded monthly? Okay, guys, take 1 minute, do it. Okay, so money double means future value is 2 times present value, and n is logarithm 2 over what is monthly? Logarithm 1.006 in period. So 2 logarithm divided on 1.0066666 logarithm 104 31 82 773. Then second step, actually let me use just the red color, divided by 12, right? So t will be approximately 8.69 years. So let me know if you have any questions regarding this exercise. Okay, can we move forward? So we have 1, 2, 3 more questions. Okay, calculate nominal annual rate of interest. 1, 2, 3, 4. Take 5 minutes, do it. Okay, let's do it. Let's do it. So, nominal annual rate of interest. The first one. So, I is 18 over 15. Now, 4 years compounded monthly. So, 4 is 48, right? So, let's see. Oh, yeah, right. 0.0038 0.5589. And as a final step, we need to times 12. Oops. Okay, let it be like that. Times 12. What is it? 0.045667064. So J12 approximately 4.5667%. They have the same answer for question 1, guys. Okay, money doubled in 7 years if compounded quarterly. So I is double. So 2, 7 years quarterly, it's 1 over 28 minus 1. So 2 exponent 1 over 28, 0.025064212. Final step is 2 times 4, right? So times 4, 0.100256848. So J4 approximately 10.03%. Okay, what about your answer? Guys, what is your answer? Okay, let me know when we can flip a page. Okay, effective rate 775. So 3, 775, M is 12, right? Monthly? Well, monthly. So what we do, invest $1 for 1 year, right? So I will be like that. Zero 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 622862, and now we multiply by 12. 00747432. Let me double check because I don't like something. Yeah, too many zeros. Too many zeros. Too many zeros. So 6239681. Now times 12. So hold on, hold on. Okay, okay, everything's fine. So 00748767178. So J12, approximately 7.4876%. Right? Finally, equivalent to 6% compounded quarterly. Nominal that and that's a booba here. We don't know how many this nominal annual interest rate compound. Let's find the effective rate. So effective rate 0.6 quarterly, right? So F approximately 6.1364%. Questions, guys? Let me know when you're ready. Okay. 4,000 debt is due for years, was paid in this much money cash. If money is worth 7%, how many months before the due date was the debt paid? Okay, do it. 2 minutes. Okay. So I don't know here, but now 4 years, $4,000. Right here is 38, 85, 35. So we need to find the T. Correct, guys? Does everyone understand the question? Okay, looks like correct. So N is logarithm future value over present value, logarithm 1 plus I, and I have logarithm 4000 over 3885 35 logarithm 7 monthly, what is that? 1.00583 period. That's the one. Okay, let's calculate. So 4,999,89,0768. Those are, I can round here to 5, right? So T, 5 months. Okay, questions? Let me know when you're ready. You see, I think we have one more question. Yeah. Make sure you understand this question. So let me know when you're ready. Okay, so question number next. Gerard owes two debts, payment 5K due in 6 months and payment of 6 due in 15 months. If Gerard makes payment 5,000 now, when should he make second payment of 6,000 if money is worth 11% compounded semi-annual? Okay guys, take 3 minutes to do it. Okay, so what do we have now? 6 months, $5,000. 15 months, $6,000. Instead of that, we make payment 5,000 now and second payment somewhere in the future, right? So focal date is today. Okay, so what do we have? Let's work separate agreements. So agreement 1 is 5,000. Now 11 semi-annually. What is 11% semi-annually? 1.055 minus 1 plus 6,000, and here is what, 15 over 12 times 2 minus 2.5. Let me make it more accurate. So 15 months minus 2.5. Okay, so agreement 1 is 4739.34 plus 5248.32. So 4739.34 plus 32. So that is 9987.66. So that was agreement 1. Do you guys have same number? Okay, I see. So agreement 2 is 5,000 plus 6,000, 1.055 negative n. Now we make that music equal 9987. Actually, do I have next page? Yes, I do. So 9987.66 equals to 5,000 plus 6,000, 1.055 negative n, right? And well, let's work it out a little bit. So 4987.66 equals to 6,000, 0.055 negative n. And here, what at this moment I say that it is present value, that it is future value. Therefore, n is logarithm 6,000 over 4987.66 logarithm 1.055. Okay, so let's calculate it. I have 3, 4, 5, 1, 4, 3, 7, 4, 3, 6. And those are semi-annuals. So I would say let's find number of years. So divided by 2, 1.725718718. If I want months, well, years, we can live like that. Or if I want month times 12, it will be 20.70862,462, so approximately 20.71 months. So it depends what units you need for answer. Those are semi-annuals, right? So any questions regarding that exercise, people? Okay, let me see the calendar. You have 1, 2, 3 weeks, right? Left. So starting next week, we will begin review for entire course. So it is good chance for those who missed classes at least to get something, right? So we will review entire course as much as we can during next 2 weeks. And then last week, which starts April 18, so April 20th will be review, and April 22nd will be final exam. Let me see Easter. Easter 2022, April 17. Uh-oh. So we lose one Friday, which is April 15, but we don't lose exam, so that's good. No. Yeah, Friday 15th week, yes. That's what I'm now calculating. That's what I'm looking at. So we finished semester on 22nd, right? So that's Friday. Actually, that's your exam date. That's your exam date. But we're gonna lose Friday, uh, Friday 15, April 15, because it is Good Friday. Because Easter is April 17. Okay, guys. So on this happy note, we finish entire course material. So we have time to review a course. I find that's good practice to refresh memories, techniques, and stuff. So see you Wednesday, and have a nice weekend. Bye bye.